Hey, welcome to the Unit 5 review video. And I would say that out of all of the units this school year, Unit 5 was definitely one that I think a lot of you struggled with. So I'm glad you're watching this video. It's going to get us through these 10 questions, and hopefully after we go through this page, you guys will be better to go on your own for the next page. All right, so diving on in here for the first one, it asks, which inequality would you flip the symbol for when solving? And it says to explain your selection below. Now I wanted to remind you guys just right here at the very beginning of the video that we flip our inequality symbol when we either multiply or divide both sides by a negative number, okay? So when we were solving problem A right here, what we would do is we would just divide both sides by a 12. That is not a negative number, so we do not need to flip. It doesn't matter about this number over here, and it doesn't matter what type of answer we get. Like for this one, even though I get a -4 for the answer, it has nothing to do with that. I'm going to leave the symbol the same direction. So for this one's answer, n is less than or equal to -4. However, for the second one here, when we divide both sides, we are dividing by a -3. So right there, I'm dividing, which is right here, I'm saying I'm dividing both sides by a negative number. What that means is when we write our answer, I'm going to turn the symbol around the other way. And then here I get a 36 divided by -3, that's a -12. So it has nothing to do with what type of answer you get. It has nothing to do with what type of number was over here in the problem. It's basically all about your coefficient. And if you have a negative coefficient, then yes, you need to flip the symbol, okay? Now, we also do need to flip the symbol when we're multiplying both sides by a negative number. So let me just briefly give you an example off to the side. If we saw that we had x divided by a -8, and we said that that answer is greater than 2, okay? I'm going to multiply both sides here by this denominator, the -8. And since I'm multiplying by a negative, I am going to turn this symbol around for my answer. And 2 times -8 is going to be a -16. So if you have a negative denominator, you need to flip the symbol. And if you have a negative coefficient, you need to flip the symbol. Those are the two times when you need to flip the symbol, okay? All right, so let's just go through a bunch of examples down here and talk about times when you do need to flip versus times when you don't. We're also going to talk about the difference in the way that these questions are asked. And that had a lot to do with why a lot of you struggled in this unit, because sometimes it wanted us to select all of the answers that we could plug in that would work. And sometimes it asked, like the next one, just for things like an inequality answer that would show us all possible solutions. So I'm going to go through that now with these two examples. In number 2 here, the variable is on this side. We have a coefficient that is a +10. I do not need to flip the symbol here. So if we're solving this one, we're just going to take the 50 and divide it by the coefficient of 10, which means we're going to keep the variable is going to stay on this side for our answer, m here, and it is greater than or equal to a -5. So one way we can get our answer is to now come through and pick everything that's either bigger than or equal to -5. And so we can go ahead and pick the -5 because of the or equal to. Remember, bigger than with the negatives is getting closer to 0. So we're not going to pick the first one, -10, but we will pick this one here. And then, of course, a positive number is always going to be bigger than the negative. Now, another strategy for this one, let's say you're looking at the SOL and you forgot how to solve, or you've kind of psyched yourself out about whether or not you should be flipping the symbol. So if I reset this one altogether, another strategy is to straight up just plug each one of them in. So for example, right here, if I plug a -10 in, I get a 10 times -10. So on that side, it'd be a -100. And we want to check now to see if -100 is bigger than or equal to the -50. That's not true, so we are not going to pick this one. Now the last one, for example, if I were to try this one by plugging it in, if I plug the 5 in for m, 10 times 5 is +50, and that +50 would be greater than the -1, so we could pick this one as a solution. So you have two options here. You can either straight up solve it, and then again, when we solved, we got that m can be everything that is greater than or equal to this -5. Or the second method, you could just take them all and plug them in and see which ones work. And again, this one would work because a -5 times 10 is a -50, which equals the -50. And right here, if we plugged in a -2 times 10, we'd get -20. And -20 is greater than the -50. So these three purple answers would work. All right, so this is us having different options to try to plug in to see if they work. Whereas now this next question asks, so which one of these inequalities below represents or shows all of the solutions to this inequality right here? Okay. So we've got 1, 2, 3, 4 options, which is basically a fancy way of just saying, hey, solve this thing right here. And we're going to solve this the exact same way we would an equation where we have a coefficient that's a fraction. We're going to multiply both sides by the reciprocal. Now when we flip this, we get a 2 over 1, but it is a negative. So we are multiplying both sides here by a negative number. This is a negative number, a negative coefficient, which means the inequality symbol needs to turn around. So here we've got 4 times the negative 2, which is the negative 8. And now we can come through and pick, and that one's going to be answer choice D. Now let's try to decide if question 4 is more like number 2 above or more like number 3 above. So it asks which value of K makes the inequality true. So it's basically asking like which one of these can we plug in and it's a true statement, which is a lot like number 2. The only difference is that this one had lots of options and it told you to select all that would work and we had lots of answers. But this one lets us know that we're only going to have one answer. So let's just straight up solve it. If I divide both sides by a negative 4, then I'm going to have that K is less than negative 3. And again, I flipped the symbol because I divided both sides by a negative. Now the issue is a lot of people are going to come through and want to pick answer choice B. But remember, K has to be less than the negative 3. And the only number over here that is smaller than negative 3 is the negative 4. So we just got to be careful if we're solving. We got to make sure not to fall for it and pick for the one that's kind of like the equation answer. We actually got to read it and make sure we pick the one that actually, like K here, is less than the negative 3. Now, for those of you who just want to straight up like plug it in and check, if you plugged in a negative 4 times a negative 4 would be a positive 16. And positive 16, that answer is bigger than the 12. So that's just, again, another way to prove that that's the right answer. Now for number 5 here, it says which value of u makes the following statement true. So 4 and 5 basically ask the exact same thing. The only difference is that right here, it straight up says that u could equal, which prompts you to plug it in. Over here, it doesn't say that K could equal the negative 4 and K could equal the negative 3, and it doesn't have to. We've seen it asked both ways, which is why I put these problems back to back here. And there's nothing right or wrong about the way they've asked it over here or over here. But again, I just wanted you to realize it's literally the same thing. So then again, over here, you could straight up solve it and divide both sides by a negative, which yes, we need to flip. I wanted you guys to see lots of examples where we need to flip. And here a 36 divided by negative 6 is negative 6. Now again, it doesn't say that u can equal negative 6, so we're not going to be picking this one, but u is less than the negative 6, and the only thing over here that's further away from 0 would be this one right here, the negative 7. And again, to check, a negative 7 times negative 6, that'd be positive 42 over here. And you guys know from the first unit that 42 is greater than 36, so we're good to go. All right, now for number 6 here. So again, practicing, it's back up to kind of like number 4, where it doesn't have to say that A could equal or A is this or A is this. But we'll just divide right here, both sides by 8. And a lot of us are going to fall for it. A lot of us are going to be very tempted to pick the 1. But A has to be less than 1, y'all. And so that means we're going to pick answer choice D. Okay? Now for number 7, it's just a translation question, and I wanted you guys to see one of these before the SOL to kind of jog your memories a bit with this. It asks, which is the algebraic inequality that translates to 6 more than a number is less than negative 2? So for these, friendly reminder, it's all about the word is. Where we see is less than negative 2, we're going to be able to write the is less than and then the negative 2. Now the other stuff we're going to translate here, 6 more than a number. So since we have the word than, we're going to take a number and let it come first. And now show me 6 more than that by adding 6 to it. So something plus 6 is less than negative 2. Now the answer choices over here, they use the letter N, that doesn't matter, but we can see right here is the one that matches, N plus 6 is less than negative 2. All right, now for number 8, we're going to practice solving, and then also I'm going to use this part of the video to practice with you guys how to graph the answers on the number line. So first, let's just solve to get the solution. Here, when we divide both sides by a negative, we are going to flip that symbol. So x here is less, and this right here would be a negative 2. So let's say the negative 2 is right here on my number line. That means 0 would be right here. I'm getting closer this way. And then a positive number 2 would be right there. And then negative 4, for example, would be right there. So if we're trying to show that x can be anything as long as it's less than the negative 2, first thing I want to review is that it's going to be an open circle on negative 2. If it had said less than or equal to, then we would have colored that in. But it doesn't, and now since it's less than, we're going to shade in this direction. Friendly reminder that from the beginning, I could have given you this problem with the 12 on this side, and then I could have put the negative 6 over here. And then I would have had the alligator symbol eating the negative 6 like that. So if we were to solve this problem, when we divide by that negative right there, you still got a negative 2 for your number line, and you still have x, and you still flip the symbol. But just be very careful if when you solve it, the variable is on the other side. Because what happens is a lot of you think that whichever way this thing is pointing, that's which way you shade, and that's not true. You would not shade over here to the right just because that symbol is pointing this way. Here we're saying that negative 2 is bigger than the x, and another way of thinking of that is saying x here would be smaller than the negative 2. So just be really careful that that still holds up, and we're still going to be shading that way, okay? All right, and now for number 9. When we see here that we just have a 15 plus x, remember if you have just the constant, you can subtract on both sides. And the reason I had this problem right here is because some of you are going to want to flip the symbol because you see that there's that negative right there, but we're just subtracting 15 on both sides. We're not multiplying or dividing both sides by a negative. So there is nothing to do here in terms of flipping the symbol. So I'm just going to keep the symbol the same way. And then the 15s cancel out. And then here 20 minus 15 is just 5. So we can put a 5 right here. And this time we're going to shade the circle in. It's a closed circle because of the or equal to. And since x is smaller, we're still going to go in this direction again because it was a less than setup, okay? If it had said that x is greater than or equal to 5, like if it looked like this, then we would have shaded in the other direction, but it doesn't say that, so we don't need to graph in the other direction. And now here, just another random scenario to kind of think back through some of these words and how these words can translate into an inequality. So for the last one here on the page, we've got that Veronica is saving money to buy a TV that costs $400. Now she already has saved $125, so she already has $125. Awesome. And she plans to save $50 per week. So $50 that she plans to save per week plus the 125 that she has just has to be more than or equal to the 400 that she's trying to save up to buy the TV. Now, when we solve this, we of course get rid of the constant first, just like we would in the equations unit. And this is like saying, all right, so if there's $400 that she's got to save up for the TV, she's already saved 125. So we can say then what she has left over is $275. So she still needs to save enough to make $275, and she's saving $50 per week. So if we now divide both sides by that $50 per week, we can see here how many weeks she needs to be saving. Now it says that she needs to save for exactly 5.5 weeks. Okay, that would be 5.5. And as long as she saved for 5.5 weeks or longer, she will meet the goal. So that's why we have the or equal to right here in the answer. Now, when we come through and read this sentence to fill in the blank, it says she will need to save for at least blank whole weeks. Since it now says whole weeks, let's think this part through. If she were to only save for 5 weeks, 5 weeks times 50 would be 250, and that wouldn't be enough. So she needs to save for at least 6 whole weeks, and then she'll have enough money. All right, so in this video, we went through the shading stuff, open circle versus closed. We talked about how to translate. We talked about when to plug in a number versus selecting all. We talked about how sometimes the question might want to see an inequality solution that shows every possible answer. And again, we talked about when to flip. But let me make sure real quick, if I put up a few problems, let's just see which ones you would flip for and which ones you wouldn't. Okay, so let's say we had x over 7, and let's say it said plus 5 is greater than or equal to negative 2. Let's say we had x plus 8 over 3, and that was less than 12. And let's have an x minus 5 over negative 6, and that equals negative 30. Or we'll put the less than or equal to symbol. All right, so just out of these three, if we're talking about when we would flip, we would only flip the symbol for this one, because when we solve, we have a negative denominator, and when we solve, we would multiply both sides by a negative 6. So here that would prompt us to flip the symbol. And then we have that the x minus 5 has to be greater than or equal to, and then this would be a positive 80, or 180, sorry, positive 180. And then you would just add 5 to both sides. And here you'd get that x is greater than or equal to 185. So remember, anytime you have a negative denominator or a negative coefficient, like if you saw a negative 3x, then you would flip your symbol. All right, this is one of the longer videos in our SLR review packet, but that one is done, so thank you for watching.